Hello, everyone. What I want you to do is I want you to, yo, what up? What is up, dog? Um, Up, dog. That's what's up. Um, Sorry. Sorry. That's one of my friends once got me in college. He goes to me, he talks to me, he goes like, yo, up dog. And I'm like, what's up, dog? What's like he's I'm like, what's up, dog? And he goes like, yeah, what and I was so confused. And it legitimately took me like 5 minutes to process what he meant by that. And then I eventually got it. So, anyways, up dog is what's up. Um, Anyways, so let's get started with our warm-up question for I don't know what that emoji is supposed to mean, but that's really funny. Okay, so what I want to do right now is I want you to um oh, so first off, by the way, there is a graphic organizer to accompany today's lesson, so you can open it up on the link right now. It's also on Canvas. But what I want you to do is I want you to answer this question. So a Toyota Prius, by the way, Priuses are great cars. Who doesn't love a Prius? A Toyota Prius can go from 0 to 60 miles per hour, which is 26 meters per second, in 10.6 seconds. Now, a Tesla Model S can go from 0 to 60 miles per hour in 2 seconds. So, which car has a faster acceleration? We have four choices for you. We have a Toyota Prius. We have B, the Model S. We have C, they have the same acceleration because they are speeding up to the same speed. And D, neither of them are accelerating at all. So let's take a few minutes to work through this. Our goal, let's hit 100% participation. We are currently sitting at about 10 out of how many? 10 out of like what? 10 out of 15. So we're looking for to get those last few responses in. So two things, make sure you open up the graphic organizer, which I posted on Canvas. And I also want you to answer the warm-up question. So a Toyota Prius can go from 0 to 60 miles per hour in 10.6 seconds. A Tesla Model S can go from 0 to 60 in 2 seconds. Which car has a faster acceleration? We have four choices. The first choice is the Prius is accelerating faster. The second choice is the Model S is accelerating faster. Third choice is that they have the same acceleration because they are speeding up to the same speed. And D, neither of them are accelerating. I would also highly recommend that you open up the graphic organizer that accompanies this because it has everything that we're going to do and has space for you to write all your answers. So you should open it up. And when you at the end of class today, submit your graphic organizer that you finished. So yeah. Okay, so we are currently sitting at about 14 out of 19 responses. Let's take another minute or two. Let's try to get all 100% participation here. We are a little low on participation right now. So what I want you to do is answer the question. We're at 15 out of 19. Let's get those last four responses in. All right, let's take 30 more seconds to answer the warm-up question. Okay, so the reveal, which car has the faster acceleration? So in this example here, the Model S actually has a faster acceleration. So in many examples, fast cars are known to have very fast accelerations. Cars like Priuses are known to not have as fast accelerations. What I want you to do now is I want you to try to create an explanation for why the Model S has a, is there like a video for proof? Um, okay, is there a video for proof? These are real numbers. These are real numbers. Um, these are real numbers. And people have actually measured the times for each one. Um, I don't think that there is a drag race of a Prius versus a Tesla, but a Tesla does have faster acceleration. It does 0 to 60 in 2 seconds, and a Prius does 0 to 60 in 10.6. And these numbers are real for sure. Um, so I don't have a video, unfortunately. I don't have either. I have a well, the family has a Prius. I don't own a Model S, nor does the family. So unless someone has both cars, I can't really race them for you. So fortunately, you'll have to sort of take my word for it to some extent. Um, but what I want you to do now is within your groups, I want to put you in your breakout groups, and I want you to create an explanation for why the Model S has a faster acceleration than the Prius. And I want you to make sure to include the two words velocity and acceleration. If the fact that the Model S had a faster acceleration, if that is sort of do your best to make an explanation of that. If you felt like they had the same acceleration, I want you to try to see if you can come up with an explanation for why the Model S actually has a faster acceleration than the Prius. So within your groups, try to make an explanation. When we come back, what I want every group to share their responses in the group chat. We are going to do I want every person to share their response in the group chat. We're going to do is we are going to do yeah. So when we come back, we're going to every group to share, every person to share what their group said. So I'm going to put you in groups, and then let's see if we can come up with an explanation for why the Model S has their faster acceleration than the Prius. Okay, so before we share our responses, we are going to do the little we're going to do the hold on, my slides are gone. We are going to do the what I want you to do is I want you to in the Zoom chat, I want you to type out your responses, but I don't want you to hit the submit button yet. So let's take maybe a minute or so. I want you to type in your responses. I want you to type in your explanation for why the Model S has a faster acceleration. I want you to type it in, but I don't want you to hit enter yet. And then in a minute, I'll tell you to hit enter, and then I will see what every person in the group has come up with in terms of their explanations. So we'll take a minute, just see if you can put down an explanation in words, have it ready to go in the chat, and then in a minute, I say hit enter, and we'll see what everyone has to say. One day I'll actually be able to film. One day when I become rich and famous, I will buy a Model S, and then I will buy a Prius, and then I will race both of them for you guys. Unfortunately, that will not happen for a little bit. Okay, but let's just for now, write out explanation for why the Model S has a faster acceleration than Prius, and then we'll hit enter in 20 seconds. All right, let's hit enter. I want to see what people have to say for your responses. So hit enter.
Mr. Hugh, I just don't know.
It's okay. So do your best here. I like the explanation you shared with me earlier. We actually have quite a few responses that I really like. For those of you who, let's see if we can get a few more. For those of you who are still typing in, just hit enter when you're ready. So it's more expensive, so therefore faster. Vroom vroom. That, I mean, it is quite a bit more faster. It is quite a bit more expensive, so therefore faster. The Tesla has a faster acceleration because it achieved the same velocity as the Prius, but in less time. Really interesting. More expensive equals faster. That is true. That is true. Though the two cars speed up to the same velocity, the Tesla Model S does so in a shorter amount of time, giving it a faster acceleration. It reaches its top speed faster than the Model S. Because the Tesla is powered by battery and the Prius has gears, the Tesla engine is able to accelerate faster. Model S has a higher acceleration because it has a higher velocity in a shorter amount of time. The Tesla Model S has a faster acceleration because it has better technologies that allow it to reach the desired velocity at a faster rate than a Toyota Prius could. Higher voltage battery, it covered the same amount of distance in a short amount of time than the Prius because it's built different. These are all really, 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 really interesting. I really like your responses. So thank you all for sharing your responses here. We will actually talk about a little bit about what this means to have a faster acceleration, but I like all of your ideas so far. So what we're going to do today, so what we're going to do right now is we are going to first going to start. Model S is more advanced than the Prius. It is more advanced than the Prius. You're 100% correct. The Model S has a higher acceleration because it has a better tech that allows it to increase speed faster. That is excellent. That's a great job, Hank. So those are some really good explanations so far. So what we are going to do is we are going to actually take a look at what this word acceleration means, what it means to have a faster acceleration. So what we're first going to do is we're going to look actually at a graph here. And before we use the word acceleration, what I first want you to do is I first want you to read this graph here, and I want you to try to answer these questions. What I want you to do is I want you to, what I have here is I actually have the velocity of the Model S plotted as a graph with respect to the time. So on the y-axis here, as you can see, we have the velocity, and then on the x-axis here, we have the time in seconds. So what I want you to do is I want you to figure out what is the Model S's velocity at 0 seconds. I want you to B, figure out what the velocity is at 2 seconds. So figure out what it is at 0, figure it is at 2. I want you to describe what is happening to the velocity over time. then I want you to figure out how much does the Model S's velocity change every second. And then I want you to predict what you think the Model S's velocity would be at 3 seconds. So just for reference, there is a graphic organizer to go with this that is posted on Canvas here. On the graphic organizer, you have all the graphs available as to well. I would recommend filling it out on there, make your life a lot easier. What I'm going to do is I'm going to put you in your groups in a second, and so you can get a chance to discuss and figure out some of these questions. Okay, so let's review this real quick. So I'm hoping that this was pretty nothing crazy. But let's just quickly go over this. So why is there no? Okay, okay. So first off, what is the Model S's velocity at 0 seconds? So on this graph here, right, what we have is we have the velocity on the y-axis. We have the we have the velocity on the y-axis. We have uh, the time on the x-axis. So we want to figure out what the velocity is at 0 seconds. Well, the initial starting point is 0, 0. So the initial velocity is just going to be 0. The Model S is not moving initially. What is the velocity at 2 seconds? What we're going to do is we're going to go on the x-axis and we're going to look at where it is at 2 seconds. It's over here, and then we got to go up to the y value here. We'll go up here, and so what we have is the y value is 26. And the reason why we look at our y value is because our y-axis is our velocity. So our velocity at 2 seconds is 26 meters per second. What is happening to the velocity over time? Well, as you can tell here, our velocity is increasing, which means that when we're increasing, it means that our car is speeding up, right? Our car is getting faster and faster and faster and faster every single second. So how much does the Model S's velocity change every second? Well, in 1 second, it went from 0 to 13. In 2 seconds, it went from 2 to 16. So it seems like every second, the velocity is increasing by 13 meters per second. So last but not least, what do you think the Model S's velocity would be at 3 seconds, right? So if every second it goes up by 13 meters per second. So it's 1 comma 13, then it goes up another 13 meters per second. So then it hits 26. If we go up another 13 meters per second, what happens is at 3 seconds, we would actually hit 39. Another way of doing this is you can also just treat the velocity here. We know we go up by 13 meters per second every second. So if we multiply this by 3 seconds, what we get is that our velocity at 3 seconds is just 39. So overall, and out of a couple of groups I've talked to, I think you guys have sort of got this one got a handle of. So I'm not going to go over this one too much more because we will actually instead move on to the next one. That I think will be a little bit more challenging. Okay, so here, the general concept is the same, right? What we have is we have a graph here. We have on the y-axis, we have the velocity. On the x-axis, we have the time. So again, I want you to answer some questions here. What I want you to do is I want you to figure out what is the Model S's velocity at 0 seconds? What is the Model S's velocity at 4 seconds? Then what I want you to do is I want you to think about what is the Model S physically doing in the first 4 seconds? Like what if you're driving a car, like what's happening in the first 4 seconds? So I want you to think about that. Right? I don't want you to think about this just in terms of pure physics terms. I want you to really be able to explain what is happening to the car in the first 4 seconds. Then I want you to figure out what is the velocity at 8 seconds. Then I also want you to think about what is physically the car doing physically in the last 4 seconds. I want you to figure out how much is the velocity changing every second. And then I want you to answer, what do you think the velocity would be at 20 seconds? And I think the last one is going to be the challenging one. So it's okay if you don't get there, but let's see if we can at least answer the other 6 questions. So once again, I'm going to put you in your groups again, and let's see if we can work through some of these questions here. If there's someone in your group who's a little unsure of what we're doing, just feel free to give them a reminder of what we're doing. So I'm going to put you in your groups again, and let's see if we can try to answer some of these questions.
Thank you.
Alrighty, okie dokie. So let's talk about this. So what is the car doing? So first off, what is the Model S's velocity at 0 seconds? It's just 2, right? We're looking at 0, 2. What is the velocity at 4 seconds? So what we're going to do is we're going to look on the x-axis, look at where it is 4 seconds. What is the y value here? It's just 0. So what is the Model S doing in the first 4 seconds? So this is actually slowing down. So it's initially going at 2 meters per second, all right? And then after 4 seconds, we are now not moving. We're traveling at 0 meters per second. So in order to do that, we actually need to slow down. What is the velocity at 8 seconds? Well, the velocity at 8 seconds, we gotta look at where the x-axis is. It's 8. It go down, it's -2. So our velocity at 8 seconds is -2 meters per second. Now, what is the Model S doing in the last 4 seconds? Okay, so this is where it gets kind of tricky. So here's what I want to imagine you. I want you to. So we're gonna imagine we're driving. I want you to put your hands on the driver's steering wheel, and we're initially driving forwards, and then you suddenly realize that, oh no, I forgot my I forgot my dog at home. No, I forgot my self-esteem at home. So you're driving and you realize, okay, I need to go pick up my self-esteem. So what happens is that you suddenly slam on the brake pedal, because you got to stop, right? You got to come to a stop, and then so you slam on the brake pedal, and then so after 4 seconds you stopped completely. Then you got to go home to pick up your self-esteem. So what happens is you switch your car to reverse, and then you hit the gas pedal. So now your car is speeding up in the negative direction. So the first 4 seconds you're slowing down, and then the last 4 seconds you're speeding up, but in the negative direction. So that's really wonky. You're speeding up, but in the negative direction. So usually when we think of speeding up, we think of our velocity as being more positive. But ironically, if your velocity is becoming more negative, you are also speeding up, just in the negative direction. So that is really weird to think about. So how much is the velocity changing every second? Well, in this case here, if we look at this graph, right, in 2 seconds, it changed by -1. In 4 seconds, it changed by -2. So that means in 1 second, it would just change by -0.5. So what would the velocity be at 20 seconds? Well, in 2 seconds, it changes by -1. In 4 seconds, it changes by -2. In 8 seconds, it changes by -4. So if we sort of continue this pattern here, what we know is that at 20 seconds, it should actually change by -10. So that means our velocity should change by -10. Not that our velocity is -10, is that our velocity should change by -10. So if our initial velocity was 2 meters per second, and it changes by -10, that means our final velocity here should actually be -8 meters per second. Okay, so now let's move on to the next one. All right, so this one. What I want you to do is within your groups, I want you to write a very brief story, nothing more than like a sentence or two that's explaining what's going on in the graph. So I want you to be able to tell a story about this graph. What's happening here? What's the car doing? So what I want you to do is write a brief story explaining what's going on in the graph. So here's some things that you may want to think about, right? What's happening to the velocity in the first second, right? What's happening to the velocity in the second second? And you might want to think about how much is the velocity changing by every second. So I want you to write a very brief story, nothing more than like a sentence or two, describing what's going on in the graph. So I'm going to put you in your groups now, and then what I want you to do is after a few minutes, I want you to have a story ready to share, and then we'll have everyone share their stories, and then we'll see what people came up with. So I'm going to open all rooms again, and you'll get a chance to see if you come up with a story that explains what's going on in the graph here.
Wait, Mr. Hu?
Yes.
What was number 5? What is the Model S doing in the last 4 seconds?
It's reversing.
Okay.
So it's reversing. It's going in reverse. but it's more, if you really want, it's as a more detailed way of explaining what's going on, it's speeding up in the negative direction.
Got it. Thank you.
Yeah. Mhm. Okay, so what I want you guys to do is I want you guys to spend a quick minute typing out your stories again, the ones you came up with. I know no one's story is gonna be perfect, so it's okay if yours isn't perfect. Just take a minute to type it out, and then in a minute again, what we're gonna do is we're gonna have everyone hit enter. So don't hit enter yet, just type out your story, and then in a minute, we'll have everyone press enter, and then we'll see what everyone else's story is. And then I'll share with y'all all my story, the one I came up with. So the one I think my story will hopefully make sense. I just want you to spend a quick minute or so typing out your story, and then after a minute we will hit enter, and then we'll have everyone share the stories, and we can see what everyone did. Additionally, so we won't cover everything today, which is okay. We'll continue picking this up on Thursday, so don't worry about finishing all of this today. We'll continue this on Thursday. So in 30 seconds, be prepared to hit enter. It's okay if your story isn't perfect, because nobody is perfect except me. I am perfect all the time. All right, in 10 seconds, get ready to hit enter. 5, 4, 3, 2, 1. Hit enter, hit enter, hit enter, hit enter, hit enter. Let's see all these stories. Let's see all of these stories here. Wow, Bryn, your story is almost completely identical to mine. So I'm actually just going to use your story instead of mine. Ooh, George, here we go. We're in a vehicle, especially, and so okay. So for those of you still typing out your stories, keep typing those out. I know we have a few different groups that had different stories here. In Bryn's story, in a parking lot, a car is reversing to leave the grocery store. As it reverses, the car is decreasing its speed until it stops and then begins driving forward out of the parking lot, increasing in speed by 1 meters per second. George, we're in a vehicle, to be specific, an APC for Modern Warfare. From 0 to 1 second, we're backing up because we're going to enemy over and could go forward us. We need to back up. We hit the brake and we were stationed for 1 second. From 1 to 2 seconds, we hit the gas because the whole square sold out. It's really good. The car's getting out of the driveway, it backs up and then stops before turning and driving forward down the street. Someone who parked by Starbucks and then leaving their parking space, they had a reverse brake and then move forward in a 1-point turn. Yes, so you guys actually, those are some really good stories. You guys honestly pretty much nailed the exact story I was going to give. So I am actually not even going to say my story anymore because I feel really lame. But what's going on is the car is initially going backwards, right? But at 1 second, it stopped. So if the car is initially going backwards and then at 1 second it stopped, right, it has to hit the brake, right? You have to slow down because you're initially moving backwards in the negative direction and then you're stopping. So you got to hit the brake pedal. After 1 to 2 seconds, right, you're going forward again. Your velocity is becoming more positive. So then you're hitting a gas. So this is where the term speeding up and slowing down can get us in a little bit of trouble because it's very easy to say that the car was speeding up the whole time because the velocity is becoming more negative. However, if we were to when we actually look at the example, the stories people wrote, right, the car was actually braking in the first second. So the car isn't necessarily speeding up the whole time. It's actually the velocity is becoming more positive. So that's just something I want us to be a little bit aware of when we're using our language here, because we want to really be able to. We want to. It's okay to say that our velocity was increasing the whole time. However, if we say that it's speeding up the whole time, right, that might confuse someone. But I think overall, I'm liking the stories people came up with. So what I wanted to do is I want us to quickly solve this problem here. So in this problem here, the car is moving at a velocity of 12 meters per second and it decelerates at a rate of 4 meters every second. What would its velocity be at 10 seconds? So let's see, how long do we need? It'll take maybe 2 or 3 minutes to work this out. Whenever you have your answer ready, type it in, but don't hit enter yet. Don't hit enter yet. We'll take till 107. 107. Also, actually 1-0. Let's do 108. Let's do 108. Give everyone a little bit more time.
Mr. Who?
Yeah.
On the graph for the story, it says the velocity is in centimeters per second. Do you want us to put our answer in meters per second since that would make more sense probably?
Yeah, meters per second. Yeah, that makes more sense. Yeah. I didn't really realize it was in centimeters per second. But thank you for correcting me. Yeah. So let's take 2 more minutes. If if an object is moving at a velocity of 12 meters per second and it decelerates at a rate of 4 meters per second every second, what would its velocity be at 10 seconds? All right, in 20 seconds, get ready. So make sure have your answers typed in, and in 15 seconds, hit enter. Let's see what we get. So get ready to press enter in 10 seconds. Type your answer in real quick. 5, 4, 3, 2, 1. All right, hit enter. Hit enter. Whatever your answers are. Oh, Harrison, hey Hank, you jumped the gun. Hey, great job, Hank. We got Hank. We got Rebecca. We got Claire. Can we get a few more? For those of you, just hit enter. Hit enter. Hit enter. We got 5. Can we get a few more? 6. Can we get a few more? 7. Jaime, great job, Jaime. Jose. Good job, Jose. Can we get a few more? So what would its velocity be at 10 seconds? So the velocity is actually going to be negative 28 meters per second. So how do we get negative 28? Well, basically what happens is that, right, our car is initially has a velocity of 12. So after 1 second, it becomes 8. After 2 seconds, it becomes 4. After 3 seconds, it becomes 0. After 4 seconds, it becomes negative 4. So in 10 seconds, right, the velocity is going to decrease by a total of 10 times negative 4. So the total decrease is going to be negative 40 meters per second. So if we started off with 12 meters per second and we decrease by negative 40 meters per second, we get is that our final answer is going to be negative 28 meters per second. What I also especially like here, I love how we all included negative signs here. I think you guys did a really good job with that. I know a lot of times I can get a little picky with those, but I think you guys did a really good job with that. So class is about to be finished. So I initially was planning to cover this whole thing today, the whole graphic organizer. I realize now that it's not going to happen. So we will continue this whole thing on Thursday. So don't worry about finishing this. I'm going to change the due date real quick. So there's no homework. Just keep up the good work. You guys did really good today, and we're going to finish up this lesson on Thursday. Yeah.
Okay, have a good day.
You too. Thank you, Hank.
Thanks, Mr. Who.
Bye.
Thank you.
See you, Jack.
Thank you, Mr. Hu.
Yeah, that's true, George. George, you got your story. Your story was great, by the way.
Thank you.
You make sure you guys write that down on your graphic organizer. I would love to read it.
Yeah, we did.
You so much.
That's good. That's good.